I think this is another example for a geometry problem where it's very useful to draw a good picture, because we will understand a lot more after we manage the good picture. So we have 3 circles. 2 of them are identical in size, and their area is given to be 5. And they are externally tangent to each other. And instead of drawing the bigger circle, I would now focus on that line, because I think these 2 circles determine that line. That line, I mean, actually there are 2 of them, starts sort of at the center of one circle, and it's tangent to the other circle. And now that we have that, we can sort of, that's a much bigger circle. Now we should usually use what is given. What is given is we have a lot of tangents here. The 3 circles are pairwise tangent to each other externally, and there are 2 tangent lines. So what do we know about circles tangent to each other? When we connect the centers, the point of tangency is on that line. But that line anyway is just a complete line of symmetry. Everything is identical. So we're just going to focus on the upper half. What do we know about tangent lines to circles? There is a right angle there, right? When we draw in the radius to the point of tangency, that is going to be perpendicular to the tangent line. So now what we have is 2 similar right triangles, right? There is this little one and there is this big one. And what is given is that the area of the smaller circles is 5 square units. What is the area of the big circle? So one thing is, I'm going to show you a trick, which I didn't start out computing things like that. I would just, attack this, and I would go divide by pi, take the square root. So it would be square root of 5 over pi. As it turns out, this is not going to be needed. I'm going to show you a little bit more of an elegant way to get to the answer. I'm pretty sure that we're going to be able to get some information on the radius of the bigger circle using what is given the radius of the smaller circle. And I think it's going to be ratio problems from similar triangles. So what do we have? Well, this is what we want. This is the little radius. And then because we have externally tangent circles, oh, would you look at that? We have the radius twice laid down. So this here is R, this is R, which I don't know if you noticed, that makes this angle 30 degrees. Because if you have a right triangle in which one side is half of the hypotenuse, that's a semi-regular triangle. So this angle is 30 degrees. And then obviously these sides are useless. So we're going to use this is not a trigonometry problem, but I would say let's go for sine of 30 in this triangle and the big triangle, right? So we have that 1, 2, 3 times we have R and then capital R. The ratio, let's say sine of this angle is R over 2R. Shall we say 1/2, which is indeed sine of 30. And in the big triangle, that same ratio is capital R divided by capital R plus 3 little r. We cross multiply and solve for capital R in terms of little r. Now, sometimes when you look back from the answer, you kind of see it already there. So what's going on? This big triangle is similar to the previous one. So this here should be 2 capital R. And this is 1 capital R, and this is the other. So we see that this makes a whole lot of sense. In hindsight, we can see sort of geometric reasoning giving us the same answer. Now, the other nice thing is that we don't have to go this route. Check this out. It's an elegant little trick, but it took me a while to get into the habit. So it might be new to you. What do we want? We don't want capital R. We want pi capital R squared. So let's just run with this. Let's square both sides. 9R squared equals capital R squared. And now let's hit both sides by pi. 9 pi r squared equals pi r squared. This is what we want. And check this out. Pi r squared is 5. We have 9 pi r squared. This here is 5. So we get 9 times 5. So we think the answer is 45. One thing before we go. So if you're new at this, probably you're going to go right away from pi r squared to r equals square root of 5 over pi. It's not that bad. I don't think there's a way around this ratio problem. So capital R is going to be 3 times 5 over 5. So capital R is going to be 3 times square root of 5 over pi. And when we compute pi r squared, it's going to be pi times 9 times square root of 5 over pi squared back. So it's pi times 9 times 5 over pi. So it's not that big of a deal if you don't go for that elegant thing. But sometimes that's available, that what they're asking is much more pleasant than that intermediate result that you might not even need. Thank you for watching.